All right, so today the first thing we're going to talk about is 10.2, and it deals with finding arcs. So first we're going to talk about what an arc is and how we kind of look at an arc. So first, the first thing we're going to look at is when we talk about our central angle. So our central angle is an angle whose vertex is the center of our circle. So if we were to look at this circle below, circle A, we see that we have our center A, and we make this angle outwards that connects to our circles. So that's a central angle, right? Main thing is that it starts with a point where the vertex is our center. So we've got two different kinds of arcs that we deal with when we're talking about a central angle. First, we have our minor arc. And our minor arc, the main thing is that it is less than 180 degrees. So if we look over at this circle, we've got two different arcs. So we've got this arc, and we've got this arc, right? So we got arc CB and arc CDB. And we want to figure out which one of those is a minor arc, and if we think it's got to be less than 180. In this case, we would talk about arc CB. And the way we say arc is we make like a little arc above our two letters. Sometimes you'll have three, which we'll see in a second. All right, so next we'll talk about a major arc. Major arc is, it's formed the opposite of a minor arc, right? So if this part here is our minor arc, this opposite part is going to be our major part. It's got to be greater than 180 degrees, which if we look from C all the way through D and back to B is definitely more than 180, because 180 is half of a circle. And so the way we'd label this arc, we'd have to use 3 points since we go through 3 points. We would have to go C, D, B, still with that arc shape above, right? And so that's how we get to our major arc. The other last type of arc we could talk about is a semicircle arc. It's an arc formed by two endpoints of a diameter, right? So if we recall, diameter means that it goes through the center. So D to B goes through center A across our circle. And we could talk about D to B in two different ways. So we could go D to B here, or we could go D to B this way, right? And so if it's a semi means part or half, we know that any semicircle equals 180 degrees. So again, you could say, right, if we wanted to call it arc DB, notice no matter which way you go, whether you go this way or whether you go back this way, you're still going to equal 180 degrees. All right, so now we're going to talk about how to find the measure of different arcs. Okay, and so the measure of an arc is the same as the measure of our central angle. Right, so up here, the measure of our arc is equal to the measure of the central angle. So if we go over here and we look at this first one, we want to find the measure of arc CB. So we look at our shape here. We want to find the measure of this arc. We have this central angle, so we know that the measure of arc CB is equal to 50 degrees as well. Right, so it measures whatever angle makes the arc is the same as your arc measure. Okay, so now we want to look at CDB, and figure out what the measure of that arc is. Think back to say, okay, the full circle is 360 degrees. And so if we know this little chunk here is 50, we get to 310 degrees. So you're kind of piecing little things together, knowing what you know about circles and what's given. Okay, so let's look at another example, a little more tricky. All right, so here, let's see. We want to find the measure of DB. All right, so since it's only two letters up here, we know we're talking about D straight to B. And we are given this central angle of 110. So then we know that arc DB is equal to that 110 degrees. Secondly, we are asked to find DCB. So that's asking for this large arc, DCB. And that DCB large arc is the rest of the circle minus that D to B arc. So if we go 360 minus 110, what do we get? 250. Okay, so we found the measure of arc DCB. And lastly, we want the measure of arc B to C. So if we go arc B to C, let's try to think about how we could do this. So if we see line, this line right here, this line DC, goes through our center, so we know that both piece over here and this piece over here has to equal what? Well, it's got to equal 180. So instead of using 360 this time, we go ahead and say, all right, 180 minus this chunk, which was 110, is going to get us this piece here, this arc here, and that gets us to 70 degrees. So again, you're using different pieces. In this case, we used that. We knew this yellow line in here was a semicircle divider, and half of a circle is 180. So the last thing for arcs, we kind of just did up here already, but we're going to put a formal name to it. So it's called the arc addition postulate. The arc addition postulate. And all it says is that if you're looking at two arcs that are next to each other and you want to find the sum of those two, you just have to add the two angles up, right? So if we want to know what angle G or arc GHE is, you've just got to add up the two smaller pieces. That's all this arc addition postulate says. So let's look at this first one. We want to find the measure of GHE. And so in order to find that, all we got to do is add up our angles, right? So we've got 40 plus 80, and that gets us 120. Find the measure of GEF. GEF. Make sure you go in order that it's listed. So GEF, this time all we got to do is, we already did our 40 plus our 80. Now we just got to add in this 110. And so that takes us to 230. Lastly, we want to find the angle of GF. Right, GF isn't adding two up, but we can use different pieces. And so for this one, we know the whole circle is 360 degrees. And we just found that this whole arc over here, GFE, is 230. And so what we're left with is 130 degrees. So it's kind of like different pieces of puzzles, right? You give or you use what you know, and you try to help that through.